NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a classic binomial expansion question. We will use Newton's binomial theorem to find the term independent of x, following a clear four-step algorithm. Step 1. Express the general term of the binomial. For the expansion of open a plus b close to the n, the general term is t sub k plus 1 equals n choose k times a to the n minus k times b to the k. This is Newton's binomial theorem general term. Step 2. Set the power of x to 0 to find the constant term. We identify the power of x inside the general term and enforce that it equals 0. Power of x equals 0. Step 3. Solve for k. We choose k so that the power of x becomes 0. K is the value that makes the exponent of x equal to 0. Step 4. Substitute the found k into the general term to write the term independent of x. Then we simplify the constants to get the final constant term. Before examples, here is a powerful shortcut. If a equals a times x to the p and b equals b times x to the q, then the exponent of x in t sub k plus 1 is p times open n minus k close plus q times k, which simplifies to pn plus q minus p times k. Setting this equal to 0 gives k equals pn over p minus q, provided k is an integer between 0 and n. Example 1. Find the term independent of x in open 2x cubed plus x to the minus 1 close to the 8. We will follow steps 1 through 4 exactly. In this lesson, we will solve a two-part problem. First, we will find the value of n from a binomial coefficient equation. Then, we will use that n to find the x-independent term in the expansion of a binomial expression. The given condition is binomial n choose 2 minus binomial n choose 1 equals 54. The expansion we will analyze is open parenthesis x plus x to the power negative 1/5 close parenthesis to the n. Step 1. We translate the binomial coefficients into algebraic form. Recall, n choose 2 equals n times n minus 1 all over 2, and n choose 1 equals n. Substituting into our equation gives n times n minus 1 all over 2 minus n equals 54. Step 2. We simplify to a quadratic. Multiply both sides by 2 to clear the fraction, giving n times n minus 1 minus 2n equals 108. Expand and collect like terms. N squared minus 3, n equals 108. Move all terms to one side. N squared minus 3, n minus 108 equals 0. Factor the quadratic. Open parenthesis, n minus 12 close parenthesis times open parenthesis, n plus 9 close parenthesis equals 0. Since n is a positive integer for binomial coefficients, n equals 12. Step 3. We write the general term of the binomial for n equals 12. The k plus 1th term is binomial 12 choose k times x to the power 12 minus k times x to the power negative k over 5. Combine the exponents of x. The exponent becomes 12 minus k over 5, which simplifies to 60 minus 6k, all over 5. Step 4. The independent term has exponent 0, so we set 60 minus 6k over 5 equals 0. Multiply both sides by 5. 60 minus 6k equals 0. Solve for k equals 10. Step 5. The independent term corresponds to k plus 1 equals 11, so the term is t sub 11 equals binomial 12 choose 10. We may also evaluate this as binomial 12 choose 2, which equals 66. Here is the problem. We want the coefficient and the power for x to the 7th. Step 1. Write the general term of the binomial expansion. The general term is t sub k plus 1 equals 20 choose k times x to the 1/4 to the power 20 minus k times x to the 1/2 to the power k. Step 2. Simplify the powers of x. Each power can be multiplied in the exponent. So t sub k plus 1 equals 20 choose k times x to the open parenthesis 20 minus k close parenthesis over 4 times x to the k over 2. Step 3. Combine the exponents for like bases. Because x to the a times x to the b equals x to the a plus b, we add the exponents. Here, that gives t sub k plus 1 equals 20 choose k times x to the quantity, 20 minus k over 4 plus k over 2, which simplifies to x to the quantity 20 plus k over 4. Step 4. To target x to the 7th, set the exponent equal to 7. So, open parenthesis 20 plus k, close parenthesis, over 4 equals 7. Multiply both sides by 4 to get 20 plus k equals 28. Then solve for k, so k equals 8. Step 5. Substitute k equals 8 into t sub k plus 1. Since k plus 1 equals 9, the ninth term is t9 equals 20. Choose 8 times x to the 7th. Final answer. t9 equals 20. Choose 8 times x to the 7th. In this lesson, we will find the term that contains x to the 32 in the expansion of open parenthesis x to the 4 minus 1 over x cubed, close parenthesis, to the power 15. We will follow a clean step-by-step method. Step 1. Write the general term of the binomial expansion. For open parenthesis, a plus b close parenthesis to the power n. The general term is t sub k plus 1 equals n. Choose k, a to the power n minus k, b to the power k. Here, a is x to the 4, b is negative 1 over x cubed, and n is 15. So the general term is t sub k plus 1 equals 15. Choose k, open parenthesis x to the 4 close parenthesis to the power 15 minus k, times open parenthesis negative 1 over x cubed, close parenthesis to the power k. Step 2. Simplify the coefficient and the powers of x. Negative 1 over x cubed to the power k becomes negative 1 to the k times x to the negative 3k, and x to the 4 to the power 15 minus k becomes x to the 4 times 15 minus k, which is x to the 60 minus 4k. Multiplying the x powers gives x to the 60 minus 4k plus negative 3k, which is x to the 60 minus 7k. So the general term simplifies to t sub k plus 1 equals negative 1 to the k times 15. Choose k times x to the 60 minus 7k. Step 3. To find the term that contains x to the 32, we set the exponent of x equal to 32. That gives 60 minus 7k equals 32. Solving, 7k equals 28, so k equals 4. Step 4. Substitute k equals 4 into the simplified general term. That is t sub 5 equals negative 1 to the 4 times 15. Choose 4 times x to the 32. Since negative 1 to the 4 is 1, the sign is positive. And 15. Choose 4 equals 1365. So the term with x to the 32 is t sub 5 equals 15. Choose 4 times x to the 32, which is also 1365x to the 32. Quick insight. Each term in the expansion has x raised to the power 60 minus 7k. To get exactly x to the 32, the exponent must equal 32. That is why we set 60 minus 7k equal to 32 to find k. Final answer. The term containing x to the 32 is t sub 5 equals 15. Choose 4 times x to the 32. In this lesson, we will find the specific term in a binomial expansion that contains x to the minus 17. We will work with the expansion of, open parenthesis, x to the 4th minus 1 over x cubed, close parenthesis, raised to the power 15. Our job is to extract the term where the power of x equals negative 17. Step 1. Write the general term of the expansion using the binomial theorem. For the k plus first term, t sub k plus 1 equals negative 1 to the k times 15. Choose k times x to the 4th to the power 15 minus k times 1 over x cubed to the power k. Step 2. Simplify the powers of x and the coefficient. X to the 4th to the power 15 minus k becomes x to the power 4 times 15 minus k. 1 over x cubed to the power k is x to the power negative 3k. Multiplying those, we add exponents to get x to the power 60 minus 7k. Step 3. To get the term where the power of x is negative 17, we set 60 minus 7k equal to negative 17 and solve for k. Step 4. Substitute k equals 11 into the general term. That gives t sub 12 equals negative 1 to the power 11 times 15. Choose 11 times x to the power 60 minus 7 times 11, which is x to the minus 17. Since negative 1 to the power 11 is negative 1, the term is negative 15. Choose 11 times x to the minus 17. Step 5. Compute the binomial coefficient. 15 choose 11 equals 15 choose 4. That equals 15 times 14 times 13 times 12, divided by 4 times 3 times 2 times 1, which is 1365. Therefore, the required term is negative 1365 times x to the minus 17. In this lesson, we will find the coefficient of x to the 50 in a long sum by turning it into a simple binomial using the geometric series factorization idea. Here is the function f of x. It starts with left parenthesis 1 plus x right parenthesis to the 1000, then plus x times left parenthesis 1 plus x right parenthesis to the 999, and continues this pattern all the way to x to the 1000. The key is to recognize a geometric style, some hidden here. We will use the identity a to the n minus b to the n equals left parenthesis, a minus b right parenthesis times the sum from k equals 0 to n minus 1 of a to the n minus 1 minus k, b to the k. We match terms by taking a equals 1 plus x, b equals x, and n equals 1001. With that choice, the long sum in brackets is exactly f of x. So we get left parenthesis 1 plus x right parenthesis to the 1001 minus x to the 1001 equals left parenthesis 1 plus x right parenthesis minus x right parenthesis times f of x. Notice that left parenthesis 1 plus x right parenthesis minus x equals 1. That means the factor on the right side is just 1. So f of x equals left parenthesis 1 plus x right parenthesis to the 1001 minus x to the 1001. We only need the coefficient of x to the 50. The second term, x to the 1001, only contributes at degree 1001, so it does not affect degree 50. Now use the binomial theorem. The coefficient of x to the k in left parenthesis 1 plus x right parenthesis to the 1001 is the binomial coefficient 1001 choose k. So at k equals 50, the coefficient is 1001 choose 50. Sometimes we refer to the 51st term as t sub 51, which equals the binomial coefficient 1001 choose 50 times x to the 50. Quick challenge. Can you explain in your own words why the geometric factorization works here? Hint, you are pairing powers of 1 plus x and x so that the identity a to the n minus b to the n collapses to our sum. Final answer. The coefficient of x to the 50 is the binomial coefficient 1001 choose 50. In this lesson, we'll solve a binomial expansion problem step by step using combinations and the idea of the independent term, the term that does not contain x. Step 1. We are given that t2 plus t sub n minus 1 equals 78. Recall that in a binomial, t2 equals n choose 1, and t sub n minus 1 equals n choose n minus 2, which equals n choose 2. Therefore, n choose 1 plus n choose 2 equals 78. Step 2. Express the combinations with factorial formulas. N choose 1 equals n, and n choose 2 equals n times n minus 1 over 2. So we have n plus n times n minus 1 over 2 equals 78. Multiply both sides by 2 to clear the fraction. That gives 2n plus n times n minus 1 equals 156. Simplify to n squared plus n minus 156 equals 0. Step 3. Let's factor the quadratic. We get left parenthesis n minus 12 right parenthesis times left parenthesis n plus 13 right parenthesis equals 0. Therefore, n equals 12 or n equals negative 13. Since n counts terms and must be positive, we take n equals 12. Step 4. Now we use the general term of a binomial expansion. The base expression is left parenthesis x times x to the 1/4 minus 1 over x to the 5/8 right parenthesis to the n. With n equals 12, the general term t sub k plus 1 equals 12 choose k times x to the 1/4 to the power 12 minus k times negative 1 over x to the 5/8 to the power k. Step 5. Simplify the powers of x and the sign. X times x to the 1/4 equals x to the 5/4. So t sub k plus 1 equals negative 1 to the k times 12 choose k times x to the 5/4 to the power 12 minus k times x to the negative 5/8 k. Combine the exponents. The exponent of x is 5/4 times left parenthesis 12 minus k, right parenthesis minus 5/8 k. Using a common denominator 8, that becomes 120 minus 15k over 8. Step 6. The independent term is the term where the exponent of x is 0. So we set 120 minus 15k over 8 equal to 0. Multiply by 8 to get 120 minus 15k equals 0. That gives 15k equals 120, so k equals 8. Step 7. Since t sub k plus 1 corresponds to k plus 1, with k equals 8, the independent term is t9. Its coefficient is 12 choose 8, which equals 12 choose 4, and that equals 495. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.